Polar coordinates. Interesting. Over 12 kilometers from port, a sailboat encounters rough weather and is blown off course by a 16-knot wind. How can the sailor indicate his location to the Coast Guard? In this section, we will investigate a method of representing location that is different from a standard coordinate grid. So this is what we have been doing. All the graphs that we worked with in the past were called the Cartesian coordinate plane. And what we're going to be working with now is a polar grid. So we'll be using a radius measure and angle measure instead of an X and a Y. So let's look at this general format of the polar grid. The positive x-axis, what you normally think of as the positive x-axis, is called the polar axis. And this point right in the middle, 0, 0, is called the pole. Your angles radiate out. Okay? So the radius is determined by how far away from the pole your point is. And then the angle, of course, is the way we've been doing it. It's this measure here. If this happens to be your angle, by the way. Okay, let's just look at an example. To plot a point, move to the correct angle and then extend the radius to the correct length. Period. Plot the point, made all kinds of typos, 2 pi over 4. So we go to the angle, pi over 4, but we extend our radius out 2 places. So this would be the point right here. This point would be the point 2 pi over 4. How about this one? Plot the point 3 pi over 2. So we go to pi over 2 and we radiate out 1, 2, 3 units. This would be the point 3 pi over 2. So what if we have a negative radius? We want to plot the point negative 2 pi over 6. Well, let's look at a positive 2 pi over 6. Remember, pi over 6 is the same as 30 degrees. So this would be about the 30-degree mark, right? So we go over to pi over 6 and out to a positive 2. Well, to make the radius negative, you walk backwards instead of forwards. So if your radius is negative, it's this direction. So the positive pi over 6 was this way. We just go the opposite direction through the pole.